Okay, let's look at resistance. Resistance is the opposition to the flow of electrical charges. So think of that little diagram at the beginning where the current is trying to flow through, and then along comes the ohm and it squeezes the pipe that the current is trying to flow through. So resistance is opposing the flow of electrical charge. If you want to define resistance, sometimes they will accept resistance is the opposition to the flow of electrical charges. But technically, it's the ratio. Remember, ratios are like fractions, so there's like some division going on here. It is defined as the ratio of the potential difference across a resistor to the current in the resistor. Okay, but sometimes they accept it's the opposition to the flow of electrical charges. So the resistor resists the flow of charge in the circuit. A resistor is a bad conductor. Okay, it's not a good conductor, so it's resisting, it's a bad conductor. Its resistance is given the letter capital R, and the job of a resistor is actually to convert the electrical energy in the circuit into other types of energy like heat or light or sound or whatever. Okay, so that's actually why we put resistors in the circuit, so that we can actually use the energy carried by the charge. If a resistor gets really hot, it's got a big resistance. The hotter the resistor, the greater the resistance. So everything in your house that gets hot is going to use the most electricity because it takes the most energy away from the charges. So like the kettle, the geyser, and the aircon, which is making things colder, they all are large resistances and they use up the energy in the circuit. So what do we know about resistances in series and parallel circuits? In a series circuit, the total resistance, which we can call the series resistance, is equal to the sum, to find the sum you add, of resistor 1 plus resistor 2 plus resistor 3. So the series resistance is the sum of all the resistances in the series circuit. So because you add them all up, the more resistors that you add, the greater the total resistance. So as you add resistors, resistance increases. So this makes so much sense. I put more resistors in the circuit, my resistance got bigger. Okay, once there's a big resistance, the current is like not happy. Okay, so the greater the number of resistors in series, the smaller the current, because the current has to come out the battery and it's little charges and they're full of energy, and then they get here, and it's really hard. And then they have to pass through this resistor, and they have to pass through this resistor, and it's even harder, and through this resistor, and it's even harder before they can go back. Okay, so the bigger the resistors, the smaller the current. Remember, the current's doing work. So if I give you homework and I give you 3 activities and I say you have to do them all, the current has to pass through all 3 resistors, you're going to be like really unhappy and go really slowly, yes? Because the more resistors, the smaller the current. But in parallel, it's another matter. Imagine I say to you, you've got those same 3 homework questions, but you only have to do 1. You are going to be so stoked. So do you do the easy one, the middling one, or the hard one? Nearly everybody's going to go woof and do the easy one, okay? Because you've got a choice. There will be some people that will do the hard one, okay? And so always in a parallel circuit, the resistance will split up, okay? But what happens is, now that the current has choices, do I go through resistor 1? Do I go through resistor 2? Do I go through resistor 3? What happens is the current gets greater because all of the charges are splitting up, okay? So this is like a very novel concept, but what happens is the more you add the resistors, okay, the total resistance decreases. So if I give you 20 items for homework and say you only have to do 1, you're going to be so happy, so your resistance will decrease. So the more resistors you add in parallel, okay, the less the resistance there is. The moment you take a resistor out, the resistance will actually increase. So to find the resistance in parallel, this formula we use this. 1 over the total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3. and you keep going with the R's depending on how many resistors you've got. The problem with this formula is it's 1 over R total. So you do all of these sums, but to get R total, you have to flip the answer to the sum. Okay, so watch out with this. So just to be clear, the more resistors in series, the smaller the current, because the greater the total resistance. The more resistors in parallel, the smaller the resistance and the greater the current. Okay, so the more, lots of resistors equals a big current, because everybody's chuffed they only have to go through one resistor, everybody else is taking a different path. So there's more current, okay, and less resistance. Just to reiterate here, be very careful when you use the parallel resistance formula. 1 over the total parallel resistance is 1 over R1 plus 1 over R2 plus 1 over R3. Your answer for this sum must be inverted, switched over to get the total resistance. You don't know how many times I've seen people do this sum and they put everything in here and then their final answer is not the final answer because they forgot to flip it. Okay, be careful. You have been warned. So this whole story that I'm busy telling you now about the resistance decreasing when more resistors are added in parallel, let's actually have a look at this properly with resistors. Here's my circuit. There's one resistor, it's 2 ohms. Okay, so my total resistance of this circuit is 2 ohms. I get another 2 ohm resistor, so I've got 2 ohms here and 2 ohms here. This is the formula for total resistance. By substituting into it, 1 over the total resistance is 1 over 2 plus 1 over 2, so it's a half plus a half, okay, which is 1. So look here, the inverse of 1 over 1 is 1. 2 ohms when I've got one resistor, 1 ohm when I've got 2 resistors. Now check 3 2 ohm resistors. We use the formula 1 over R total is 1 over R1 plus 1 over R2. A half plus a half plus a half is 1 and a half here, 3 over 2. But we have to flip this, so it becomes 2/3, which is 0.0667 ohms. So can you see we went from 2 ohms to 1 ohm to 2/3 of an ohm. And now if I whack 4 resistors in there, a half plus a half plus a half plus a half, this gives me 4 over 2, okay, which is the same as 2, but it's 1 over RT, so I have to flip the 2 and I get a half. So my resistance has decreased the more resistors I add in series, in parallel. Okay, so the more resistors in parallel, the resistance decreases. This is really, really important to remember. If we look at resistance calculations, there is what I call the quick and dirty. So sometimes this is much easier to do than going the 1 over R1 plus 1 over R2, because this one gives you the answer automatically. Okay, so if you've got only 2 resistors, you can't do this with 3, but most of the time you've only got 2 resistors. So if you've got 2 parallel resistors, you can multiply the resistances, R1 multiplied by R2, and then divide by R1 plus R2. So your resistance will be the product of the resistors divided by the sum of the resistors. And if you're doing your homework and you look in the memos, you often find this in the memos. They use it all the way up to grade 12, but they never ever put this in the formula sheet. So this is something you have to learn on your own, or otherwise just go back and use this formula so long as you apply this formula correctly, and remember to flip your answer. So this is the quick and dirty. It's the fastest way to find the answer if you can remember it, but it's not on the formula sheet. Okay, we call resistors in a series circuit potential dividers. Remember when we talked about voltage, you remember that the total voltage is the sum of the voltage over all of the resistors. So resistors in a series circuit are called potential dividers because the total potential difference provided by the battery is divided between the resistors. But resistors in parallel divide the current. Okay, remember the current's like when you've got all your options for your homework and everybody goes through the easiest homework question. So resistors in parallel are current dividers because the total current is divided in between the resistors. Now, resistance belongs with Ohm's law. Okay, Ohm's law is technically not in grade 10, so you don't need to learn the definition, but Ohm's law always comes up in resistance questions, even though it's not in the CAPS document for you, so we need to look at it. Okay, so Ohm's law says, and you can learn this for next year if you stay in physics. Ohm's law says the potential difference over a resistor is directly proportional to the current flowing through a resistor, provided the temperature of the resistor remains constant. So this temperature must remain constant, because if you increase temperature, you increase resistance. Remember that from grade 9, okay? So we measure resistance in ohms, and an ohm is 1 volt per amp, because it's the potential difference over a resistor is directly proportional to the current flowing through the resistor. And when you work this into a formula, the resistance and the proportional and the what, it works out to this formula. The resistance equals the volts divided by the amps. It's the potential difference over the current. So to work out resistance is R is V over I. Now this formula is the proper way of stating Ohm's law. It is not in the grade 10 data sheets normally, sometimes in the provincial exams, but if you look on your data sheets that I gave you at the beginning of the year, it's not there. The easiest way to remember it is this way, V equals IR. So I always remember it as V equals IR, and I often talk about it as V equals IR. Okay, so try and remember V equals IR, and then you must know how to use it, because for some reason they stick it in there even though the CAPS document says that you don't have to. Okay, we do talk about Ohm's law in grade 10 though with this, okay? If a conductor obeys Ohm's law, we call it an ohmic conductor. So if you keep a temperature constant, the resistance will stay the same. So most metal conductors obey Ohm's law if their temperature remains constant. But now a light bulb has got a very high resistance, and these filaments in the light bulb, these little wires are called the filaments inside the light bulb, they are non-ohmic conductors because they get very hot and then their resistance varies, okay? So they're usually made out of tungsten, FYI. So light bulb filaments are non-ohmic conductors. And we will come to factors affecting resistance in the next section.